the cost. So we are going to ignore what he makes. We just want to know right now the cost to run his business. All right? 450. Now, will it be... Why don't you help me write out the cost function? His cost as a function of x is, we said the fixed cost was 420, right? Okay, I'm going to put that at the back. Plus his variable cost, you said, was 450 x. Now, if we do it this way, do we agree that that 450 is a positive number here?
Oh, no, it's negative. It's negative because he spends.
He is spending that, but he's also spending this, right? So I'm seeing some looks like, what? This function is supposed to tell us how much money he's having to spend to run his business, right? So we said it's $420 plus 450 times x. Now, what is x? We haven't even talked about what x is here. That's the visits. Okay, that's very clear here. X is the number of visits that he's going to do. In other words, the number of dog walkings he's going to do, visits. So if he does no visits, what are his costs? 420, right? If he does one visit, it's 420 plus 450. Those are things he's going to have to put out of his pocket, right? So if we're going to have this be a positive number, this also needs to be a positive number. All right? We good with that? Mm-hmm. That is our cost function. Let's see if there's any more to this problem. There should be more. There's not more. There's not more. Let me make up my own then. What is his revenue function? Now, we haven't even talked about revenue because this is not a business math class, but revenue is the money coming in. All right? So can we come up with a linear function that represents his revenue as a function of the number of visits he does? 15x, right? 15x. Now the 420 we wouldn't have here because this is annual. So look, this is how much it's going to cost him as a function of the number of visits he does, right? We already talked about this. This is how much he's going to make, revenue, right? Coming in per walk. Agreed? Now, what do you think? Do y'all know what the last type of function there is? You have a cost function, a revenue function. Your profit function. I'm not going to test you on this, but we went this far, so there's a difference. You may hear these terms like when you're watching the news or something, the difference between revenue and profit. So cost is what goes out. Revenue is what comes in. And what do you think the profit is then? Whatever's left over, right? So that's your revenue minus your cost. It's your revenue minus your cost. That's your profit. So what would happen if I took this function right here, 15x, and I subtracted from it 450x plus 420. Notice the parentheses there, very important. If I took this and subtracted the whole cost function, I have to put the whole thing in parentheses like this. And then that negative distributes through. Look, on a test, this is all I'm going to ask you for right here, okay? This is all I'd want. But I feel like I need to take this the rest of the way. All right. Let me write down what this is. This is going to be our profit function is, what's 15 take away 4.5? 10.5. 10.5. So we get 10.5x. And then we distribute the negative through minus 420. This is his profit function right here. This is it for his business. So can you tell me right now, if he has this company and he doesn't do any jobs over the year, how much is he going to make? He's actually going to be negative 420. He's going to be out of pocket 420. Does that make sense? Mm-hmm. Now, if he does one dog walking, then he's going to make $10.50, right? Because he makes $15, but he has to pay for the gas. So he'll make $10.50, but then subtract $4.20. He's still in the red, they say, right? How many visits do you think he would have to do to break even?
42.
Probably close to about 42, somewhere around there. Okay, we're getting beyond it. I just wanted to kind of finish that up. Yeah. We have one last type of problem, then we can take our break. Let's look at that one right there. Okay, so I'll read this one. These are called mixture problems. And these problems are not necessarily linear. So these are no longer really going to require linear equations, all right? This is just a completely different kind of topic. So let's read through this. If there is a mixture of 2 liters of 10% butterfat milk and 1 liter of skim milk, how many liters result and what is the percent of butterfat? Whoa, okay. So when you go and you buy milk at the store, when it says like 2%, something like that, that's giving you the percentage of fat in the milk, all right? This is saying that we have 2 liters of 10% butterfat milk, and then we have 1 liter of skim milk, which has no fat in it. So I'm going to draw a picture for this. This is 2 liters of the 10%. And then we have 1 liter, right? 1 liter. You don't have to draw a pretty picture, okay? 1 liter of 0%, right? So there's our 2 containers. The first question is how many liters will result if we mix these together? What we're going to do is mix these together. So how many liters would we have in the resulting mixture? We'd have 3 liters, right? That's obvious. Just add them together. So when we mix them, right, we mix them, and what we get here is 3 liters. The question now is what is the percent of fat in this mixture? How do we do that? Okay? That's what I need to show you, but do you understand the question? So here's how I'm going to do it. I would like for you to tell me of this 2 liters, if you were able to separate the fat from everything else, the liquid in there, how much fat would you have in there in liters? So in here, I'm going to imagine that you separate, this is the fat down here. My question is, how much is that in liters?
0.2.
0.2, how are you getting that?
Because there's 2 liters and it's 10%.
That's right.
So
10% of this is fat, right? 10% of 2 liters is the same as saying 0.10 times 2, which is 0.2. Make sense? What if we said 50% of this was fat? Then it would be 1 liter of fat, wouldn't it? It's like half of it would be fat. So if you say 10%, you do 0.1 times that 2, and you get 0.2 liters. So that's how much fat's here, right? How much fat's in here? Nothing. 0 liters, because it's 0%, right? Agreed? You sure? When we mix them together, stir it up, right? How much fat is in here now? How much fat's in here? It's still 0.2, right? 0.2 liters. Why is it 0.2 liters? Because we took this fat and this fat, mixed them. Well, this is 0 and this is 0.2, so we still have 0.2, right? We have 0.2 liters, but how many liters are there in this thing?
3.
3 liters, right? So to find the percentage, to find the final answer, what we do is we take the 0.2 and we divide it by how many liters there are, 3 liters. So on your calculator, do 0.2 divided by 3, and this will give us our percentage as a decimal. What do we get here?
.0666666.
0.0666, so let's just leave it like that. Liters, sorry, that's it right there. And then we convert that to a decimal. This is approximately 6.6%. We're about to take a break, but we're going to do this problem again. But I'm going to change some stuff here, okay? Just so you can see this we go through the operation one more time, okay? So what you do is, to do these problems, you figure out how many liters are here, how many liters are here, and that'll figure out how many liters in the mixture. You figure out how many liters of fat you have here, how many liters of fat you have here. That'll add them up, and that'll be how many liters of fat are in the mixture. Take that fat, divide it by this liters, and that gives you the percentage. Does it make sense that if you mix 10%, 2 liters of 10% with 0%, mix them, that you should have less than 10% fat in there? And we do. We have 6% now. Someone had a question? No? I thought I saw a hand go up. Did you change your mind? Okay, so I'd like to change this problem, all right? Here's what I'd like for us to do. I'd like for us to say that there was 3 liters of 10% fat, okay? So I'm going to change all this. And now we're going to mix that with 4 liters of 20% fat. I would like to know the same thing. How many liters of mixture do I have over here? And what is the percentage? Okay? So first question, Marcus, how many liters will I have in the mix? 7 liters. Okay, so that we just add, right? Jared, there you are, okay. Jared, how much fat do I have in this first container?
10% or
10% of 3, which would be 0.1 times 3, which is 0.3, right? Liters of fat. That's how much fat I have here. Elizabeth? How much fat do I have in the second container? 20%. So in liters, so 0.2 times 4, which is going to be 0.8 liters. That's how much I have here. That's how much fat I have here. That's how much fat I have here. So of the 3 liters that I have in this mixture, 0.3 liters of it is fat. Of the 4 liters I have here, 0.8 liters of it is fat. So, Tanisha? I've lost where I am here. What's that? Where? Okay, Tanisha, how many liters of fat do I have in this mixture? How many liters of fat are there over here? That's right. You just add these two together. Add these two, so you would have what is that? Or 1.1 liters of fat here. Do you want to keep going? Because I want the percentage now. Divide. Take this and divide it by 7. There you go. So now to find the final answer, you take the 1.1 liters of fat and you divide it by the total number of liters in the mixture, which is 7 liters. And on a calculator, what do we get there?
6.3636.
% So you already went to a percent? Or did you, oh, yeah, I think you divided the wrong way. 1.1 divided by 7.
Oh,
0.157.
0.157. Okay, so as a percentage, 15.7%. Seeing it a second time, does that help? Does it make sense? You have a little bit of this 10%, you got a little bit of this 20%, you mix them together, you're getting something that's about 15.7%. If you ever take a chemistry class where you do a lab, a lot of times they'll have things in the back like acids, and they'll have like a 10% and a 30%, but maybe in the experiment they want a 20%. And so what you do is you mix them to get the concentration you want. It's similar sort of thing happening here. All right, we're going to take a break. Let's say 12:30 we'll resume because I've got to go down to my office, pick up the stuff. So it's 12:17. We'll continue at 12:30. All right? I'm actually going to stop the video right now.